Go ahead and do an example to round this out. Example 2. Okay, so we're going to let f of x, y, we've seen this vector field before, equal minus y over x squared plus y squared, and x over x squared plus y squared. Okay, now c of t, so this is our vector field. Our curve is going to be the unit circle. We're going to do cosine t and sine t, and we're going to take t from 0 to 2 pi, that's the unit circle, and S, our open set, is the entire plane, because this vector field is defined over the entire plane, excluding the origin. Because the point 0, 0, this vector field is not defined, excluding the origin. Okay, well, let's go ahead and form f of c of t. We're going to evaluate this directly. So f of c of t is equal to minus sine t over 1, right? Because if I put cosine t for x, sine t for y, cosine squared plus sine squared is 1, standard trigonometric identity. And this is going to be cosine t over 1. Now c prime of t, that equals minus sine t and cosine t. Okay, so when we form f of c of t dot c prime of t, when I dot these two, I end up getting sine squared t, right, minus sine t, sine squared t plus cosine squared t is equal to 1. And let me see here, as equal to 1. So now we're going to, let me do this on the next page. So now the integral of f, the integral of our vector field over our unit circle is equal to the integral from 0 to 2 pi of just 1 times dt, which is dt. And that's going to equal t from 0 to 2 pi, which equals 2 pi. 2 pi does not equal 0. This implies that there does not exist a potential function. Let me write. There does not exist a potential function for this particular vector field on this particular open set, the plane with the origin deleted. If it were equal to 0, then we can conclude that a potential function exists. In this particular case, a potential function does not exist for this vector field. Now, if our open set changes, a potential function for this vector field may actually exist. So again, don't draw any conclusions. This is one open set. This particular open set is the entire plane with the origin deleted. If I took another section of the plane that has nothing to do with the origin, maybe something in the first quadrant, something in the second quadrant, third, fourth, wherever. So this is specific, so don't draw any other conclusions that the problem, in other words, any value that you get, any conclusion that you come to is valid only for the particular open set that you're dealing with. This particular vector field may or may not have a potential function if the open set is actually different. And I'll let you think about that or work it out in your problem sets. I'm sure this is a vector field that you will see over and over and over again. So with that, thank you for joining us here at Educator.com and Multivariable Calculus. We'll see you next time. Bye-bye.